We're also going to use substitution to solve this system of equations. Just like the previous one, we already have y isolated in each of them, which means we can take our value of y from the first one and replace it into the value of y into the second equation. As I rewrite the equation, y equals negative 3x plus 5, and then now I just rewrite the other side, negative x minus 11. I now have a situation where I have variables on both sides, so I need to collect the variables to one side and then solve for x. I always like to move the letters to the left, although it doesn't really matter. So I'm going to do that by adding x to each side. At this point, I have a two-step equation. Subtract 5 from each side, follow the rules of algebra, divide, and you have x equal to positive 8. Excuse me, that should be a positive 8. Now, after you take that value, you can take that value and plug it into either of the original equations. I always say plug it into the easier one. Honestly, it doesn't really matter here. You're going to do a number of steps for either. If we plug it into the top equation, and we have y equals negative 3x plus 5, and we're going to replace that x value for what we just solved for, which is a positive 8. And now I'm going to do negative 3 times that positive 8 plus 5. Negative 3 times 8 is negative 24. Negative 24 plus 5 is going to give you negative 19. And then, of course, you have to write your answer as a ordered pair. So this system has a solution of 8, negative 19.